Welcome to Equine Assisted World. I'm your host, Rupert Isaacson, New York Times bestselling author of The Horse Boy, The Long Ride Home and The Healing Land. Before I jump in with today's guest, I just want to say a huge thank you to you, our audience, for helping to make this happen. I have a request. If you like what we do, please like, subscribe, tell a friend. It really helps us get this work done. As you might know from my books, I'm an autism dad. And over the last 20 years, we've developed several equine-assisted, neuroscience-backed certification programs. If you'd like to find out more about them, go to newtrailslearning.com. So without further ado, let's meet today's guest. Welcome back. I'm your host, Rupert Isaacson, and I've got Dr. Chantel Prat with me today, who's a neuroscientist. And as you know, in our work, movement method, horse boy method, technique, we like neuroscience because we tend to be working with the brain and the nervous system. So it's sort of logical for us to look to neuroscientists who hopefully understand about such things for mentorship. So I'm excited to have Chantel on today. Chantel's also a horsewoman and has dived into that side of neuroscience as well. So we get to ask her some questions about horses' brains, but also about the interaction between a human brain and what goes on with horses, because those of us who are involved in the therapeutic and equine-assisted world need to know these things. And because the science is rapidly developing all the time and changing, we sort of rely on people like Chantel to keep us up to snuff. So Chantel, welcome. Thank you for coming on. Who are you and what do you do?
Thank you so much for having me. You might have noticed that I laughed a little bit when you said Dr. Chantel Prat. It's true. I am a doctor, but I'm also a first-gen college student. My husband and I both were raised by people with high school educations. And I think I got my PhD in 2004, but it's still more often than not someone is making fun of me when they call me Dr. Prat because I've just crashed into a hole with an ice cream cone or something like this. But nonetheless, yes, it is true. And I really deeply believe that science is an important way for asking and understanding these big questions that at the end of the day feel almost more ethereal, or I was going to say metaphysical, but like when you were talking about myself as a horse person and myself as a neuroscientist, I thought like both of these are really hard things to understand. And I just want to start by saying, I'm going to give you my credentials and what have you. But I just want to start by saying that probably because of how long I've been studying these things, and I'm talking, looking at pictures of brains, doing the numbers, working with baby and older horses, and I have a huge amount of humility, and I probably am much more aware of all of the things I don't know than the things I do know, because these are really complicated questions and really intense, immense goals. So that being said, I am a neuroscientist, a psychologist, and a linguist at the University of Washington in Seattle. My research for over 25 years has been looking at individual differences in how the brain gives rise to the mind. So I am a cognitive neuroscientist by training, which is a fun thing to say when somebody asks you at the bar, because they either will leave you alone, pretend to understand what it means, or ask the question. But, neuroscience is a huge field, and some people are really, trying to understand it at the chemical level, and some people are very interested in the nervous system from the neck down, the body and the spine and all of that important stuff, vagal and et cetera. And I have really been focused on the sense-making aspects of the brain, and not just the sense-making aspects of the brain, but how our individual biology and experiences give rise to the way that we connect the dots when we try and understand the world and our place in it. And this is huge. We were talking, I started by saying I have a lot of humility about this, but I just want to point out that our brain is about 86 billion neurons. It's one of the most, if not the most complex systems studied by humans. It's totally crazy to get into the idea that your brain is studying itself. So all of the limits we have in understanding the thing are It's a closed loop system here. But even though the brain is complex and powerful, it's finite, and it tries to understand and operate in this infinite world full of energy that is constantly changing by taking discrete bite-sized chunks of information and then connecting the dots. We're constantly trying to figure out what's going on now based on what's happened to us in the past. And we're constantly trying to predict the future, but we really don't. Like, our understanding of the now, the past, and the future is just largely inferential. It's largely connecting the dots, and people see, think, and feel differently because they have different brains and different experiences that have shaped those brains.
Tell us about your book and the studies that went into that book, because this is really seems to be at the heart of your work is looking at individuality
Yeah.
and what that means. So
Yeah.
tell us about it.
My book is called The Neuroscience of You: How Every Brain is Different and How to Understand Yours. And, the book was created with the goal of helping people understand themselves first and foremost. I think, I've been arguing that theories about how the brain gives rise to the mind that are one size fits all, which is the vast majority of research that exists, don't fit anyone very well. It's just like one size fits all t-shirt, right? It's down to your knees or not. And importantly, I think in that process of helping people understand themselves, I hope I'm laying a foundation for helping people to relate across differences. So if we think that there's one way to learn well, if we think there's one way to be intelligent, if we think there's one style of decision making that is good, we operate in this totally false paradigm that makes us see differences as better or worseness, right? We naturally line up like, oh, I'm smarter, I'm better at math, I have a good memory, and the truth is that humans are social primates. Our brains evolved to solve problems collectively in groups, in small family groups mostly, or small tribal groups. And because of this, and because of their vast power, and because we can never understand the infinite, ever-changing world, these differences are features, not bugs. There are trade-offs in the different ways that we can be. And the book talks about things that vary from introversion and extroversion and how that's explained by our dopamine reward system, to whether we are like strongly right-handed, strongly left-handed, ambidextrous, and what this says about how jobs get assigned to our two hemispheres. Always looking at trade-offs, always looking at the match, rather than saying this brain design is better or worse, looking at what is this brain design well designed to do? What is the match between what I am asking my brain to do and my natural predispositions and the things I've learned from my previous experiences? So, I mean, I'm about, when we get off this podcast, I'm going to start week 10 of a class that I'm teaching here at the University of Washington with 30 undergrads who have gone through the book, done a lot of what I call me search, right? Done a lot of tests to figure out how their brains work. And probably the thing that I'm proudest about is to hear people move from saying things like, I'm bad at attention, or I'm bad at memory, or I'm, this way and that way, to saying like, there's a trade-off, or I know that I'm better at this than that. And just that's the sort of self-acceptance and awareness that comes from understanding, from moving from a sort of strength deficit idea towards thinking about the match between the environment and what you're asking your brain to do.
Of course, the environments that we find ourselves in are largely determined by economics, right? And so the diversely expressed brainishness of the human species, which I presume must be across all mammalian species, presumably comes about because any natural environment has an infinitude of potential things that can happen. And you might specialize. So you might be more hunter or gatherer. If you're within hunter gatherer, you might be more running hunter or bow hunter or tracker. You might be more medicinal plant person. You might be more really able to discern between plants that almost look the same as each other, doppelganger type plants, or you might be the person that can really get up well in the trees and shake down the nuts. So you could definitely see why all of this infinitude of brains would evolve. With
And
any
I
kind
think
of
more so in animals that exist in packs, right? So I think that there are
right,
evolutionary. So I think that, like, this is not a brain thing, but I always compare the human brain to the peacock tail, where it's like, okay, you can say if this peacock's tail is better or worse than this peacock's tail based on how long it is or how colorful it is, or, so I think in like less collaborative animals, there probably are things that are more adaptive than others, but there are always differences. But
right.
the way
So I guess
selection has unfolded for humans, we selected for differences for sure.
right. So we also have the ability to pool our knowledge, right? So
Correct.
and make strategies.
Mm-hmm.
This seems to be our biggest superpower. We're sort of victims of our own success,
Yeah.
perhaps. But you could also see how we've arrived in the kind of culture that you and I live in at a point where economically now we've almost specialized our environment to a point where only certain types of brain can thrive in an easy or straightforward manner, and other types of brain get undervalued,
Mm-hmm.
and for real reasons, because within that more narrow economic confine, indeed, there are only like these 3 or 4 types of brain that, really do well with that, and all those other ones perhaps not so much. And this leads us into, or is a question, does this lead us into a false set of assumptions about normality, and where we think normality is being able to conform to that narrow economic construct, whereas in fact that narrow economic construct itself is an abnormality in the sort of greater history of mankind,
Mm-hmm.
and therefore we're actually mistaken, but we're sort of right and wrong at the same time. And then if you come along with someone like me who would say, well, my experience of maths at school in the way that I was taught means that I think I'm bad at math. Later on, when I had to homeschool my son in math, I realized that being bad at math was actually kind of a good thing, because it meant I could empathize with somebody who was and I could look at how to break things down. So I had to understand it first, and if I could understand it with the difficulties I had, then there was perhaps a sporting chance that he might, or they actually turned out to be better than me, of course. But I guess the question I'm asking is, do you still feel in this day and age of the recognition of diversity, which is different to when we were kids, that the sort of narrow idea of what's normal and what's not normal, and what's a good brain and what's a bad brain, or has that now not all broken down a bit, or am I just living under completely false illusions because I work within this field and think that people are actually are people still stuck in these ideas of normal? And yeah.
Okay, so there's two things I want to address. The first is about this particular the definition of good being based on what makes money or what functions in the way we've set up Western societies. And then you started to answer the question by talking about teaching your sons. I think it starts in education. I think the big problem is actually how education is set up, not how industry is set up. And I think that our educational systems are largely set up. I mean, it just boggles the mind, because education is set up from a time in which only the teacher had the knowledge, and you're supposed to sit still and listen, because you have to transfer in this laborious way knowledge from one brain to another. And so far we have evolved as a society, not as a brain, because where the brain is coming from, written language is still new and hard. So when you think
Right.
about Chat GPT and all this stuff, like we've come so far, but yet we still have this model in which kids are supposed to sit still and passively absorb instruction. And that is so far from how any brain evolved to learn and problem solve, that I think, the challenges when it comes to value and what we value start much earlier than in the economic
Right. And you talk about,
world.
there is a correlation between that and industry because, of
Right.
course, making kids sit down, shut up, and
Yeah.
behave was part of preparing them to go work in factories.
Sit in
And
front of
that was
sit in
where,
front of a computer and
yeah, yeah. So, I mean, does not
yeah.
one create the other?
Yes, but not necessarily. I think both, to your question about where are we now, I think both are coming to understand and appreciate differences for different reasons. So like I would argue, and I am on the advisory board for Ariana Huffington, who founded the Huffington Post, has a company called Thrive Global, and it's about wellness in the workplace. And we're creating a training there about diversity in the workplace and specifically about the benefits in decision making that come when you have different brains with different backgrounds at the table. So I think I would argue that there is an economic advantage to considering many different brain types, to having people who think, again, as we evolve to think and make decisions in groups, to valuing people with these different brain types at the table. And when you create work environments that support different kinds of thinkers and deciders, and you incorporate their ideas, you also create products that work for more kinds of thinkers.
Mhm.
So there and so I think we are at a sort of turning point where I've been spending more and more time with C-level execs who understand that diversity is not only about sitting around a table with people who look different than you and think the same. That's not it. That's not the magic sauce. It's sitting around a table with people with different experiences and different brain types that they can bring into this decision-making space, and learning how to appreciate these different perspectives and find something that will work well for more people. That there are a
It
lot of advantages in that space.
is industry actually now refinding the hunter-gatherer model because
I
industry
hope.
itself has become so diverse. It used to be
Mhm.
a factory was sort of a factory and it
Mhm.
ran with an assembly line and and it's now looking very, very different. And in a few years, robots will do all that anyway.
Mhm.
And are we at the point now, this interesting point where we're returning to a sort of hunter-gatherer economy, but that's post-industrial, where
Mhm.
we actually now suddenly realize, oh my gosh, yes, we do need to create products for all these different brains. But this is
Mhm.
actually, again, quite new since the Industrial Revolution. Things were
Mhm.
more homogenized. Interesting that you're there. What what you say you're working with these CEOs and so forth? What are they saying about this, and and then how are they able to make their work environments possible for
Yeah.
people with these different brains? That's not just lip service saying, "Well, we're going to hire
Right.
so people on the
Right.
spectrum, we're going to
Exactly.
hire so and so, but they're
Exactly.
going to
That's
just go and shred paper or whatever."
Yeah,
Like, yeah,
exactly. Exactly. And so I think that's the real work. So your vision of returning to hunter gatherer is quite interesting, because that's the work, is that naturally, I think because of the way that we understand one another, there's all this really interesting social neuroscience work that shows that if we're in the wild and we're moving around choosing our friends, we choose people who work like we do. Like you can predict, they did this crazy, fascinating study on an island in South Korea where they created a social network of like 700 villagers and then stuck them in a scanner and measured their brain connectivity and showed that you could predict who would be friends with whom based on how similarly their brains were wired. And that this explained, friendships above and beyond things like age, politics, personality, so long as they live close enough to have come into casual contact. When we're choosing people to spend time with, we choose people who work like us. And I think that's because our sort of default to mirror neurons and so forth and so on allows us to make easier intuitive inferences when somebody works like us. Now, in the workplace, I think that often how this translates is when they say somebody is not a good fit culturally. Like, there are these kind of like code words when you're in hiring, and you might say it's not a good fit for the culture, and I think that that's a feeling that comes when the person you're interviewing has a different brain, a different thinking, feeling, behaving style. And I also think that we are more likely to think someone who comes up with the same solution as we do is smarter, right? Because you can understand that solution, you agree with it. And so you're like, oh, yeah, this is a great person to have on my team. It's like duplicating, triplicating myself, cloning myself. And so people need concrete examples and evidence. It's hard. It's certainly harder to create communication styles, to create management systems that go away from assumptions about how people think, feel, and operate towards, more personalized, individualized spaces that support these differences. And they need concrete examples for how this is going to make them money, right? And how the decision making will look, because it's not going to feel like, oh, this is great, you're brilliant, I love you. It's going to feel weird. And so that's where I think my book has helped give some kind of engineering examples. Like, this is how brains work. These are the weaknesses that are associated with all these kind of fast, instant, probabilistic decision making. This is what you're missing. And so getting people to feel curious about the brain across the table that is saying something that you might think is asinine, or doing something that you might think is asinine. That's, I think, the magic and the secret sauce, because every brain does things that they think are perfectly reasonable. Every single brain is moving through the world trying to find good things and avoid bad things based on their engineering and their experiences. So instead of thinking, why is this idea asinine, asking questions about how that person got to that place is this kind of opening experience for sort of reconceptualizing better, worse, right or wrong with, what am I missing? What is this person highlighting that I missed?
I just wrote curiosity underlined.
Yes, curiosity is the magic. It's my favorite thing that I learned about in writing my book, and it's the secret sauce, I think.
Yeah, I agree. And, without curiosity, there's no innovation. Without innovation, there's no long-term thriving economically, right? Because conditions change. So one has to, whether it's in a hunter-gatherer context, there could be a drought, there could be some natural thing that causes the shifting of natural resources. Obviously, market forces, we're seeing some disruptive market forces going on as we speak here in March 2025. It's an interesting time. If you're not curious, I mean, how can you thrive in these things?
Right.
I want to bring you back though to, you talked about mirror neurons. Mirror neurons are something which you hear a lot of people talk about. But I've just caught a neuroscientist on the end of my screen. Tell us exactly what mirror neurons are.
Well, I can tell you exactly how they were discovered, and then I can tell you about the ambiguities of them, right?
Please.
So a mirror neuron at its core is a neuron in the brain that is both involved in generating an action in the person themselves, and when they observe someone else doing an action. So it was first discovered in Italy in a monkey lab, where they were actually they had electrodes in this monkey's brain, and they were putting fruit on a tray in front of the monkey. And what they wanted to see is like, what part of the motor cortex executes a specific grabbing response. So there's a lot of brain is involved in just motor programming. And what they found, so they had, these motor cortex neurons isolated for this monkey's hand. And what they found was the experimenter, who was a human, by the way, obviously. I guess. I mean, it'd be really
So
cool.
I should be
I
surprised.
mean, it would be really cool to have monkeys. But anyway, it was a human that
Italian
had
monkeys, no less. Yeah.
exactly. They're very social and very, very smart. But when the human put like the fruit, the treat on the tray, they used the same grasp, the same motion that they were trying to study in the monkey. And they found these neurons started firing. These neurons that were supposed to be for motor programming started firing when they saw someone else do the action that they're supposed to do. So we know that there are populations of neurons in the human brain that are both involved in it's really important for language. For instance, there are neurons in and around the sort of speech Broca's area that will listen to speech sounds, and they sort of activate the motor plan that would create those speech sounds, and that helps them
Where in the brain are
understand.
these located?
Mostly in the frontal cortex. So they're mostly I would say both sides of the frontal cortex. Now, what happens is, I think so the criteria for something to be a mirror neuron specifically is that I both generate a behavior and I respond when I see other people doing that behavior. And so like, in the original research on animals, we had an electrode in the brain, and we were really specific about what was going on. Now I think that the research has gotten fuzzier, because when you're looking at human brains and you don't have electrodes in them, there are a lot of parts of the brain that do a lot of different things. And so, to the best of my knowledge, neuron research has become controversial in some areas. So like one of the things that I think is quite evocative is the idea that mirror neurons are involved in empathy. And one of the reasons I think this is evocative is how hard it is to just, is empathy a single thing? How hard it is to define empathy, how hard it is to catch a brain being empathetic. And so usually when they study, you have to think about this. If you're thinking about flow or like creativity or things that are really cool that we actually want to understand, if we can't time it to the precise millisecond, if we can't catch it in action, if we can't cause it, how sure can we be that we're studying it? So with empathy, often what they do is watch somebody get hurt. It's like a physical pain empathy. And then you're looking at like activation in the sort of somatosensory areas, and, similar, like you see somebody get hit with a ball or something, and you look for like the feeling of pain.
Yeah. They get hit in the arm and clutch your arm. Right.
Yeah, right. And I definitely feel, that's why we have, I probably shouldn't talk about this, but like we have a divide in my family about nutshot videos and whether or not they're hysterical. I like feel it. I obviously don't have testicles, but like I feel the pain from those so viscerally that I can't.
They are both painful and funny, I'd say.
But my husband and my daughter think they are hysterical and will cry and just watch like endless nutshot videos. So I'm like, okay, is that something different about our mirror neurons? Like, I don't know. It certainly crosses gender, so I don't know what's going on there. But that's a very specific kind of empathy, right? So to the extent that generalizes to cognitive pain, to emotional pain, I don't know. But when it comes to how we understand one another and how we understand our horses, I think this is fascinating, because the idea is that mirror neurons is kind of a way of understanding through simulation, right? Like I watch you do an action, the part of my brain that would execute that action activates, and I think, ow, or whatever, but I think this is why we're drawn to brains that work like ours in the wild, because this isn't mirror neurons are intuitive, instinctual. It's not learned. It's why little kids cover their eyes and think they disappear. This is the easiest way of understanding one another, I think. And so if you and I have totally different wirings, and I'm watching you behave and I'm simulating it and I'm thinking this is asinine, my brain is different. So when my brain walks through, thumbs up, when my brain walks through what it would be doing in that case, and I have all these different priors and I have all these different wirings, and I think that makes no sense whatsoever, then it's like stepping into shoes that are a different, walking a mile in someone's shoes that are a different size. So that's where I think the more, what Paul Bloom, I think, wrote a book called Against Empathy, a case for rational compassion, where he talks about understanding in this more what we call theory of mind way, which is a more abstract, clue-based, use the information to reverse engineer somebody else. And I think that kind of theory of mind understanding is not as warm, it's not as effective, but it allows you, I think, to understand people who work differently than you do. Like you might, and with the horses, I think it's interesting to consider how much we're feeling with a horse and getting it wrong because the horse has a different experience than we do, versus using the bits of, the bits we've learned about how horses work to kind of rationalize what might be going on.
Just quickly, just to beat the dead horse on mirror neurons. Am I correct in thinking that a mirror neuron is not just a mirror neuron, that a mirror neuron might do other things, might have other jobs it does as well, of which the imitation thing is just one function, but they could equally do other things as well? Or is it dedicated?
I don't know the answer to that. So I think that, they have at least two jobs. One would be executing the behavior in you. Like you don't only, so I guess maybe that answers your question. That part of the brain in the monkeys is firing when they're trying to grab a grape, whether they're seeing someone else do it or not. So it is involved in social imitation and learning, but it has a primary job in controlling your body.
So if we're involved in the sort of therapeutic riding end of things, which obviously a lot of people listening to this show are, what I presume that trying to optimize people's mirror neuron development would be a useful thing because it helps them to learn how to thrive in a confusing world by kind of learning which behaviors to emulate. What's the best advice that you would give to somebody working in, say, an equine assisted field who wanted to help somebody optimize their mirror neurons?
Optimizing for other people, or?
Well, for both. I mean, because I should imagine cross species, if you talk to a lot of autistic people, for example, they'll say, well, it does feel like I'm dealing with another species when I'm dealing with you. So whether I'm dealing with a horse or whether I'm dealing with a neurotypical human, whatever that is. And then similarly for neurotypical humans, when they're dealing with people on the spectrum, it can feel like dealing with another species. And this is where the communication breaks down. So how can we help ourselves out neurologically as the practitioners so that we can help our, if you like, service users?
So my instinctive response is that, to the best of my knowledge, and I will admit that I'm not an expert in this, the mirror neuron system is I'm so hesitant to use the word innate, but I guess what I would say is I would, rather than trying to train the mirror neuron system per se, I would be trying to train explicit behaviors. Like if the mirror neuron system is working atypically, because this is something you see in infants, you see them imitating facial expressions.
Right, what we call milestones, etc.
Yeah,
Those milestones are not happening, right? Yeah.
Right. So, it's either been unfolding or not unfolding, typically up until the point of intervention. So, what I would be doing is making the things that might be implicit to us explicit to the learner. I think that that's a more tractable learning technique,
Put
right?
that in terms that somebody walking around an arena with a kid on a pony in Staffordshire on a Tuesday night can understand and put into practice.
So again, are we trying to get them to understand the pony or the instructor?
That's a good question.
If you're in the equine assisted field, or if you're considering a career in the equine assisted field, you might want to consider taking one of our 3 neuroscience-backed equine assisted programs. Horseboy method, now established for 20 years, is the original equine assisted program specifically designed for autism, mentored by and developed in conjunction with Dr. Temple Grandin and many other neuroscientists. We work in the saddle with younger children, helping them create oxytocin in their bodies and neuroplasticity in the brain. It works incredibly well. It's now in about 40 countries. Check it out. If you're working without horses, you might want to look at movement method, which gets a very, very similar effect, but can also be applied in schools, in homes. If you're working with families, you can give them really tangible exercises to do at home that will create neuroplasticity when they're not with you. Finally, we have taquine equine integration. If you know anything about our programs, you know that we need a really high standard of horsemanship in order to create the oxytocin in the body of the person that we're working with, child or adult. So this means we need to train a horse in collection, but this also has a really beneficial effect on the horse's well-being. And it also ends your time conflict where you're wondering, oh my gosh, how am I going to condition my horses and maintain them and give them what they need, as well as serving my clients? Taquine equine integration, aimed at a more adult client base, absolutely gives you this.
Because for the pony, like I would say, do you notice what his ears are doing? Like, what do you think that means? You know, and how does that look compared to this pony's ears? Like,
Right.
you know, what can we learn from this? And like with the instructor or with, you know, Billy, you could say like, you know, when you said, hey, shut up or whatever just happened, like, you know, what did you notice? You know, did you see this thing? And you can like point out.
Now, what if that all sounds highly reasonable, and now what if the person doesn't have the kind of brain that can receive information in that way, sort of top-down instruction? So what if they're like severely autistic or away with the fairies in whatever way, and you want to help to bring them into this type of empathetic cognition, so that not so that they can be changed, but just so that they don't get their ass kicked too heavily by the world that they're in. How could we? What are some things that spring to mind for you
So
to
the
help
thing that,
kickstart that process? Theory of mind,
Yeah.
effectively.
yeah, the thing that makes sense to me based on my understanding of the brains of people with autism is that the thing that you want them to learn about, you've got to restrict distracting information. So you would need to simplify the world to the extent that you could make the learning item of interest the most salient. So I hear you saying like, I'm on a horse and my brain is not verbal or it's not programmable in this way. And part of that is because the things that they pay attention to are not as predictable as the things that we pay attention to. Like you in a neurotypical individual, there are certain things like social cues, like language, like faces that take priority a lot of times over things that would be very salient for someone with autism, like repeated motion. Of course, that's what we're working toward, or like machines. Anything that's predictable is something that might help attract their attention, which is kind of the exact opposite of the noisy, chaotic human face and voice. So I guess, and I'm sure people have done this because it seems obvious, the learning should be happening in a situation that is as free from other kinds of distraction as possible to make the cue, so when I think of mirror neurons, I think of a match between what you're seeing and what you're doing. And to the extent that such a thing could be trained, you would want to just eliminate as many other kinds of distracting things as possible. So I've read about, for instance, vocabulary development in autism, and it's fascinating because, in a typically developing brain, mom can take a pen and go point to it and say pen, and there are all these, you're listening to mom's face, voice, the point, there are all these social cues that point you to the attention on this object. And a typically developing kid with autism is like, listening to the finger, the butt, the way the socks feel on the shoes. Like you might learn any amount of this sensory information might be capturing your attention.
You know, it's really interesting. When I was first having to get involved in this, because I had to because of my son, there was, and there still is, a belief among some people that say a wall with art on it or something like that would be too distracting. And so people would be working in these really very sterile environments, white walls, frankly depressing aesthetically.
Yeah.
But I found, of course, going out into nature with my kid opened everything up.
Yes, and that makes so
there
much
were
sense to
multiple
me.
distractions, but those distractions seem to work for us, not against us. So my question with that is,
this gives me a good idea. Okay, keep going.
okay, is this because those distractions didn't have a bad sensory effect because they're the distractions that our organism is set up for, i.e., the wind, the light, the trees, or whatever. So therefore, they're not really distractions; they're just sort of our habitat. And then do our brains that automatically respond better to those? And then the other thing was, of course, it was all in movement, and that brings me back to what you were saying earlier about with factories and schools. The brain didn't evolve to learn and problem solve that way, sitting still. So I made a little note to myself, say, ask about movement and the brain. So nature, movement, okay. And then what I would do, of course, was look for what seemed to motivate him from these.
That's exactly what I wrote.
And then just go in that direction.
That's
the
exactly
reason
right.
I did it, though, was not because I was intelligent. The only reason I did it was because I'm not intelligent. And because I know that I'm not intelligent in that way, I went for mentorship from Temple Grandin, who told me to do that as an autistic person. So I, as a journalist, went, well, she's autistic and she's successful, so she must know what she's talking about. So therefore, I will do what she says because that just seems rational. And I did, and it worked. But I definitely found that following what sometimes behavioral therapists would have called distractions, I found were not distractions at all. They were motivators.
That's right.
Right.
That's right.
So what's going on with the brain? And
so there's some, my gosh, like there is a person here at UW called, his name is Gregory Bratman, and there's a team that are studying nature wellness interactions. And in so many different ways, sort of nature and mental health. And like the first thing that I thought about when you were talking about walls with no art and versus nature is this idea of soft. One of the things that seems to be true is that when we are in nature, we are inherently softer in our focus. We're more like the horses, right? Like we have this wide picture. And I do think that that's very settling. It's restorative for the nervous system, right? Because we also have something called like attentional fatigue. And I think, as you were talking about the white walls and things like this, I thought, okay, how do you get from distracting to like a stressful amount of pressure in one area, which will then fatigue your brain and your nervous system? And I think this kind of soft focus, which you also get, we know this is true from moving, right? The rhythm of walking relaxes the nervous system, and it opens up creativity and opens up like the ability to think and reason and learn. So that's the first thing, is that this is the way we focus in nature. We need to be aware, we need to be alert, we need to know where we're putting our feet, which is kind of cool and interesting. But we're not necessarily hyper focused on something that will fatigue the brain. We have a kind of broader awareness, which seems to be, from a mental health point, restorative. And you're right. That's how we are meant. We are animals, and that is how we are meant to exist. It is. And I think it's in this space of normal value, what's good and what's bad. I worry so much about how removed we are from how many things that we think are bad about our brains that are just absolutely the way that we are designed to exist. Our brains have not evolved nearly as fast as our society, the pressures that our society has put on them have.
What do we think is bad about our brains that we could be wrong about?
I think attention is the biggest thing. Like, my students, like, and I think that this is I also want to talk about your question about, do we think diversity is accepted or not? I think it depends. Attention is a huge thing. Like many people, like you're saying I'm not intelligent, but I think that's because you have a very specific idea of intelligence that's like sitting in front of books like I am right now and digesting things and, and remembering them when they have like no tangible purpose in your real life, or like, how well did you absorb numbers on the chalkboard when someone gave it to you without a context? And when it comes to, I just think that there's a very straightforward way that your brain defines intelligence. Your brain defines intelligence as learning the things that will move you through the world and help you find good things, period. Right. And so having the ability to like undergo 6 hours of class a day for 25 years of your life before you finally get a job where you make money and can then buy the good things is like that's not very natural. That's a lot of delayed gratification. Right. So I'm thinking about nature. What did you ask me? What's a good brain?
That you talked about attention. So
yeah, attention. So a lot of people feel they hate, like I at the beginning of this class, I would hear my students saying, I hate my ADHD. Do you know how many of like in my students, I'm at the University of Washington, and it's widely considered one of the 10 best public schools in the world. I think that could be changing, and so these students are at the top of what society would call high functioning intellectual. And I probably have about 25% of the students in my class, this upper division, like neuroscience class, with diagnoses of ADHD. And I think there's something in that, right? So either we can say, and if you look at incidence of ADHD, it really depends on the country. It depends on the time period. It could be something that's increasing because of, digital stimulation. It could be something that's being more widely diagnosed because of awareness. But the fact is that 1 in 4 students have this diagnosis means that it's not rare. It's not atypical.
And it also means it can't be that bad of a thing, right? Otherwise,
it can't be
they
that bad
wouldn't
of a
be getting
thing
into University of Washington.
Exactly. And in some ways, but the students will say, I hate that. And then I say, okay, well, let's talk about the opposite.
Did they say why they hate it, by the way?
I think they hate, well, they will say, like, I don't know why I can't be motivated to sit and do something for a long period of time, or that I then get hyper, they're aware that they also get hyper focused and like down a rabbit hole for something that they say like wasn't important. And so one of the things that we've learned in my class is like when you are, what widely in both this kind of economical world and in a classroom, what's widely considered valuable or good is the ability to pay attention according to some goal, right? Like I'm telling you, pay attention to what I'm saying because we're on a podcast right now and that means whatever. Or, I'm telling you, pay attention to your homework, or I'm telling you, pay attention to dropping your heels or whatever, right? And the ability to, but like when people are paying attention, first, it's expensive for everyone. That's why it's called freaking paying attention. It uses the frontal lobes. When you're paying attention, what you're actually doing is you are overriding everything you've learned from trial and error experience.
No, that's interesting. Okay.
So like everything you've learned about how to stay alive, how to find the good things, you can override that to now focus on a specific piece of the world and ignore the other pieces of the world.
For a specific outcome, right?
For a specific outcome. It costs a lot from an energetic perspective, and you are literally distorting the world as it is. And you are less likely to see something that you're not expecting.
Right.
So, if you don't have someone with ADHD in your hunter-gatherer group and you happen upon a cave with eyeballs popping out of it, you're dead.
Yeah.
You're over here counting blueberries like you're supposed to and see how many are in the basket or whatever. And you're not even seeing the eyeballs in that cave.
Yeah. No, absolutely. And that's always been my thought about ADHD is that, having lived with hunter-gatherers, you can see how the human brain has to be able to operate in effectively multiple parallel universes,
Correct.
and at the same time hyperfocus, and at the same time allow itself to be distracted.
And isn't it convenient if you have different people who are good at those things and can communicate with one another?
Right. So you can defer to, you're better at the blueberries than I am. So when it comes to blueberries, I'm deferring to Chantal. So then maybe I can give Chantal the chance to go down the blueberry rabbit hole, because we'll all benefit from that. And I'll watch out for bears while she's doing that, because she knows more about blueberries than I do. When it comes time to do the thing that I'm good at, she'll do the same, blah, 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 blah. But, and then, the need to change on a dime and pivot. So if you're hunting, conditions change like that, the wind changes, or the animal hunts you back, or you realize another animal is hunting you while you're hunting, or whatever it is. And so if you can't then pivot very, very fast, well, you can't get food. So I've often wondered when people talked about ADHD, does ADHD, why is there a D on the end of it? Why is it a disorder and a deficit? So it's only a disorder and a deficit, presumably, if it no longer fits the economic model. So,
that's right. And in fact, the diagnostic criteria, I talk about this from time to time because I study attention and attentional differences in the lab. And there are a number of tests you can do about distractibility, focus, goal, orienting, you can break it into a million different boring tasks. There's no criteria. There's no, if you get this score, you have ADHD. That's not how you get diagnosed. You get diagnosed.
Subjective.
It's if you, is this impairing your ability at home, work, or whatever, right? In context.
Okay.
So that's about functionality. It's not about typicality.
Well, right. And then that depends on what's being valued at home, presumably.
Correct.
So if the home culture is that I, as an 8-year-old boy, should
sit still,
behave like a Philadelphia lawyer.
Yes.
There might be a small percentage of boys that can do that at 8. But if you're not one of them,
then you start to feel like there's something wrong with you.
dysfunction, then it means that we've gotten very narrow in what we perceive as an economically viable thing, right?
Yes. Yeah.
Instead of so diversity, you talk about diversity, one thinks about it as diversity of people, diversity of brain types, but there's also diversity of economics, right? Surely, we need multiple skill sets, people with multiple skill sets.
Yeah, and Temple Grandin is big about, she is so, tuned into that as well. And like, we're under training for really important skill sets. When we had dinner 2 weeks ago, she said that her new passion is going around looking at all the certificates everywhere in the world that have not been checked, like the elevator certificate.
Yes, she does.
And I was like, I don't like elevators to start with. You're not helping me at all. She's like, they're everywhere. Like
she came and spoke at the conference that we did in September, and the first thing out of her mouth when she got on the floor, she says, I just checked the elevator coming up here and it's out of date by and we're like, okay, all using the stairs.
yeah. Comforting. But hey, awareness is key.
Indeed. What part of the brain, just quickly about attention, what part or parts of the brain govern attention?
So I would say the attention is an interaction between the frontal lobe. Well, it depends on the kind, right? So there's natural, or I call it organic attention. Some people call it distractible, but I love it because squirrel is, that's the kind of prototypical distractibility. But hey, man, squirrel is an organic attention. That's
squirrel is also edible.
Yeah,
squirrel. Right? I mean, why wouldn't I look at a squirrel? I might be able to eat it in a hunter-gatherer context.
Yeah, or you might be able to make friends with it. Here,
they're
quite aggressive stealers of lunches. Might be your competition.
Yeah.
But so there's two things. One is that you have a frontal lobe that holds the goal in mind if you're paying attention. And two is that you have these basal ganglia, which are my favorite parts of the brain, which are the dopamine-rich reward centers that learn based on previous experiences where to find the good things. Now, the basal my husband has a really cool computational model about this called conditional signal routing, which, by the way, we found was working quite differently in autism. And the idea is that when you have a goal, the frontal lobe can help change the rules for what good looks like, right? So like if ice cream is good. And you feel hungry and there's ice cream, you're like, this is a high probability reward. But if you're like energized enough to hold in mind that you want to live to be 100 and that you haven't eaten any vegetables, the frontal lobe can tell the basal ganglia, hey, like right now, actually fiber or things that grew from the planet are good in a way that aligns with these goals, and you can make a different decision.
So it's your basal ganglia, your impulse, and your prefrontal cortex, what you're talking about there, that could override that impulse to change what's good.
Kind of. I think the basal ganglia are a lot smarter than just impulse. I think they're at any given, the frontal lobe gets all of this. I think of the frontal lobe like the CEO that gets all of this credit for making decisions, but the basal ganglia are already filtering behind the scenes based on your previous experiences, say this information is particularly important for making your decision.
Where are they located, the basal ganglia?
Right in the middle of the brain.
Why are they called ganglia?
I don't know. I think that means
they
multiple.
Gangle?
Yes, I think
I always imagine them like Octopussy alien.
We had Halloween costumes
type things, dangly, tentacly things.
We had a Halloween costume collective. We were called the Basal Gang. I think it means multiple ganglion. I think it's a thing, but I don't honestly know. And then there's this, so it seems also within this frontal and then inner basal ganglia system, there's also a left and right ideas. And I think this is super interesting. The left seems to be more goal focused and predicting the future, whereas the right seems to be more focused on the now and noticing abnormalities or things that move and so forth and so on. So for instance, there's a disorder called visual neglect or hemifield neglect. If you get damage in the right hemisphere, the left hemisphere can still kind of like figure out what's going on. But if you miss the noticing hemisphere, you might just like ignore an entire half of your body. So there's this different kinds of awareness in the two hemispheres, which is quite interesting. And if you have people bisect a line, so we did this in my class, just give people a bunch of lines and have them draw a line where you think the middle is, you can get, and then measure how close you are to center. You can get some idea of whether you have this more, or, if your right hemisphere, if the line is to the left of center, it means that your left hemisphere is driving your noticing more. And if the line is to the right, you can say that you have like a more organic brain. So ADHD people are more driven by the right side.
Okay. And we live in a bit of a left brain society, so therefore it's a disorder suddenly.
Right.
Whereas in another culture, it would be an asset.
Right, exactly. And I think that applies to a lot of different skill sets and a lot of different ways of being that we're, sort of underappreciating. And, going back to your question about the first question, which I feel like I never fully answered about, where are we at in the acceptance of diversity? I love that neurodiversity is searched for 4 times more frequently on Google now than 5 years ago. I think that there is a general awareness that probably 1 in 5 people have some kind of what will be diagnosable as atypical brain organization. And I love, these stickers that say neurospicy and this kind of acknowledgement that I think that there is a general increase of awareness and a general increase in people claiming that they're neurodiverse, like making it public, having the neurospicy sticker, and understanding that this is not a personality deficit. This is just the way my brain works, is kind of stepping into that recognition. However, I think there's work to do. Number one, I think that understanding that this is not like a personal weakness or a deficit, this is just the way my brain works. I think that there's room for that in the typically developing population as well. I think, like I said, with my students, people who don't understand why they're distractible, don't understand why they're not motivated to do boring things, don't understand why they forget. Forgetting is as important for learning as remembering. Like, I just think there are a lot of things about our brain designs that we perceive as character flaws because of this kind of societal value of a particular thing that's very abnormal. And I think there are certain labels that are more popular than others. Like ADHD is so metal and rock and roll, and yeah, I'm neurospicy. But like when I talk to people who are on who have autism spectrum disorder, many of them don't want to be the person on that panel, or don't want their employers to know about it, and are worried about being stigmatized, and are worried, so like it's, I don't think we're there yet when there's like a cool disorder and a not cool disorder. And again, I think that I just think the work comes to it with normalizing differences. We're all different. And people with an Asperger or an autism spectrum disorder label are just as different from one another as people without it. Like, so assuming that label lets you know, oh, I don't know, like people make very weird assumptions. And when they want me to talk about neurodiversity in the workplace, they want me to say something like, eye contact is aggressive, or like that it's not true for everybody, or like not everybody thinks in pictures, not everybody this, there's diversity within and between these labels. So I think normalizing differences and rethinking about deficits as just a mismatch between the thing that we're asking our brain to do and what our brain is good at. And to your point, strength building, working with the nature of our brains, working with the things that we're passionate about, because literally no one gets lit up by doing boring things. No one does. And that takes us back to curiosity. Do you know that when your brain feels curious, it is, first of all, it requires safety. You cannot feel curious when you're not safe. And when your brain feels curious, it emits dopamine in anticipation of an information reward. The same basal ganglia that looks for food the human brain treats information as a reward when it's something you're curious about. And when that dopamine comes online, dopamine is something that is not actually for reward. It's for motivating learning. So it motivates you to work, and your brain gets rewired more quickly. So I guess like when you started talking about your son, and then you said you worked with what motivates him, my second answer to that person who's got a kid on a pony is learn about that what lights them up, and put it into that. There's a study that was actually done in, I think it was Nigeria, that's so brilliant and so easy. They were teaching kids math, and they gave them, and this was like secondary school math, and they gave them a 10-minute interest survey. Where do you like to shop? What do you buy? Who are your friends? What's your name? And then they did this math instruction where they personalized the problems. So Rupert went to the store to buy whiskey.
IPA.
Yeah, there you go, an IPA. And and then you do the math in that. And of course, you and I know this because we're parents. The kids who had the math wasn't taught differently at all. It was just taught in a context that the kid cared about, which meant that you get curiosity kind of by periphery.
Sure.
And they learned more. And so this is like in my writers group, I had a friend tell me, you're like one of those moms who puts vegetables in dessert because I'm curious about the brain and I don't want to be. And like, yes, that's the secret sauce.
It's interesting. We have a whole thing within Horseboy method and movement method of before we see someone trying to, as you say, get as much info as we can. Mm-hmm. And we want to know all the motivators. We want to know if they're into Pokemon, well, what aspect of Pokemon, who are the characters, what are the, and we'll tailor it all around that.
Yes.
But also what do they hate?
Yeah.
And we find that that's as important too. So, and that's sensory, right? So they hate this, that. So we're going to, great. These things there's perhaps back to your point about distraction. We can then try to eliminate as much as possible those smells, those noises, those characters, those types of things from the environment that we're going to work in. So that, and if we then maximize the things that are the motivators, well, then presumably we've got a better chance. But one thing I often see in the therapy world, sadly, is a lack of curiosity. And I think within the horse world, this can be particularly endemic, sadly, that we horsey people are quite bossy and quite opinionated, and we don't like change. So we hate admitting that maybe we need to rethink something, or, we'll usually die on nail of how we've always done it. And obviously that's not massively helpful when we're dealing with our horses. It tends to make us stuck. But of course, if we're then trying to take a therapeutic approach, that lack of curiosity is going to shoot us in the foot fairly massively. Presumably that lack of curiosity can't be really endemic because humans are curious apes. So here's a question. Do we have curiosity trained out of us? And can we retrain it? And what part of the brain do we need to target for that, and how?
So there are sort of state and trait differences in curiosity. Some people are more curious by nature than others. And there are also different kinds of curiosity, or perceptual curiosity, people who want to feel things, and epistemic curiosity, which blows my mind. It's strange, as much as it's true of me, that people want to know things, want to know that jellyfish could essentially be eternal because they can like go back a stage developmentally. It's like, how will that ever help me in life? But it's so fascinating,
Because it makes you optimistic.
Yeah, you're like, oh,
it makes
somebody
you
can do it.
generally optimistic, which means you assume better outcomes, which means you probably will get them.
Right. And so there, in the jellyfish example, you have highlighted where curiosity, like, where does it come from? And is it trained out of us? Absolutely, yes. I think, and depending on the discipline, sometimes it's very explicit, like, don't ask questions, do what I say. But I think we know the recipe. I think there's a pretty good recipe for curiosity. And my favorite is a model by Gruber and Ranganath. Charan Ranganath was one of my professors in grad school, and it's called the PACE model. So it's easy, PACE. So number one is predict. So if you think you know the answer, if you think you know what's right, you're not going to be curious, right? And that's like to that point of we get stuck in habits. If something surprises us, if something doesn't go as planned, or we find ourselves in a new situation, that's where we have the first opening. And that's where I think, like, for me, like, humility about what I don't know keeps me like always curious. So prediction failure is the first trigger. It needs to be something you don't know everything about. But also, if it's something you know nothing about, you're probably also not curious because you're trying to make connections. You want to integrate everything into your knowledge of the world and your place in it. Then the important part, I think, is the assessment. Number two, am I safe? And if you're a hunter-gatherer and you find something unexpected, if you make a wrong turn on Google and you find yourself in the wrong place, if you're in a situation and your conversation is not going as planned, the question is, am I physically safe? Am I psychologically safe? And I think this is something that corporations haven't been spending enough time with, when there's like best answer, right? It's like, in order to make people feel curious, it's not like be curious and be the best or you're fired. Like, that just doesn't, that kind of like environment does not promote curiosity. So in the training out of curiosity, it's like, how do we treat answers that are different than what we wanted? Are we like, no, that's not right? Are we focusing on deficits? Or are we like, oh, tell me what made you think about that? Like, where did that come from? What do you know that led you to that answer? So psychological and physical safety are precursors. You need to be in a place that you can't predict. You need to think you don't know the answer. You need to feel safe. And then once your brain has sort of gone through those two steps, you experience curiosity. And the point of curiosity is to motivate exploration. That's the E. So curiosity, explore. And what's beautiful about this is, I would say these first two, predict and assess, are what my trainer, Gabby Noor, who I love, calls getting your horse or yourself into the learning frame of mind. They've got, and I think it's true of your kids, your students. You want to do the work first before you do anything to get them into the learning frame of mind. They've got to feel safe. They've got to feel engaged.
Got to build a relationship. The environment's got to be right. Yeah.
And then you have this curious learner who will learn, the rewire more. Period. Like, if I gave you 10 questions, I asked you trivia questions and I asked you, which are you the most interested in learning? And then I gave you the answers to the all 10, you will remember the ones that you were most curious to learn better, because your basal ganglia has said, this is interesting to me. This is an information reward. and it's predicting a reward. It's motivating you then. Like one of my favorite studies actually had people risk electrical shock to learn a magic trick.
Wow.
Because
I
there
would do
is,
that.
yeah, exactly. So and there is this aspect of curiosity where it is potentially dangerous, right? When you're in the unknown, and especially with perceptual curiosity and trying drugs and things like this, right? It's like there's often a risk reward benefit, and when we're curious, we're super motivated to find information, and we'll
Well, we
do
also
work.
know that we can't avoid risk, so we need to, like, if you hunt and gather, it's risky, right? So
Right.
being on planet Earth is risky, so we need to dance with risk. We need,
Right.
yeah.
Right. And so that curiosity in this study, the more curious they were to learn the magic trick, the more likely they were to take a risk to get a shock. Like, okay, it's a 20% risk. Okay, it's a 40% risk. Like, when do you say, no, I don't really care about the magic trick that much?
Right.
But what was but that basal ganglia, that filtering part of the brain that's sending information to the frontal lobe that I said is smarter than just impulse.
Right.
When people took a risk for an electric shock, the basal ganglia turned down the volume on the part of your brain that might simulate what the shock feels like. It turned down connectivity to the hand.
The basal ganglia has that power?
Yes, it has inputs from everywhere in the brain, and then it sends repetitive things to the frontal lobe. It turns up or turns down the world. That's the kind of filtering. So when it's like, no, we really want to know this. Like, I think that this magic trick is really important, and we're not going to think about what the shock would feel like when you make this decision. So, it's a major motivator. So in your learners, I think, and of course, like, back to our idea about what's gone wrong in schools and what goes wrong in horse training, I think all the time too. It's like, if you make this thing feel incompetent, wrong, threatened, if one of those 8-year-olds who doesn't want to sit still and behave like a lawyer already thinks there's something wrong with them, they already feel threat in these environments.
Right.
We've already shut down the curiosity that makes learning not only fun. I think to your specialty, I think something that is like completely overlooked is we're meant to learn to find the good things. And like learning has taken on this serious, whether it's learning to ride horses or learning to do math, it's taken on this serious reputation, which is in and of itself antithetical to how we were designed to learn. We were designed to learn. Learning is supposed to be fun. We're supposed to, like, the fact that we feel excited about something is our brain's way of saying, we think this is going to be useful. We think this is going to be interesting. We think this is going to be important. And so everything else created equally, something you do to make learning fun will also make it more effective.
If you're a horse nerd, and if you're on this podcast, I'm guessing you are, then you've probably also always wondered a little bit about the old master's system of dressage training. If you go and check out our Helios Harmony program, we outline there step by step exactly how to train your horse from the ground to become the dressage horse of your dreams in a way that absolutely serves the physical, mental, and emotional well-being of the horse and the rider. Intrigued? Like to know more? Go to our website, heliosharmony.com. Check out the free introduction course. Take it from there.
Talk to us about the relationship of movement with this and neurotrophins, BDNF, and so on.
This is a little bit farther out of my area of expertise, but I do know that we evolved to solve problems on the go, right? So moving the body, again, is something that regulates the nervous system and puts us into a state of alertness that helps us focus on what it is we're learning. The challenge then becomes presenting information while walking or presenting information and then going to move through the world to
Well, what's interesting with that is so, for example, the two other languages that I sort of speak are French and German. I learn them on horseback. So I'm balancing, I'm problem
That
solving.
makes perfect sense.
Got the BDNF is going, that brain derived neurotrophic factor thing, but also I'm motivated to be there. I want to be on the horse, right? And I'm motivated to learn this vocabulary about horses because I'm just intrinsically interested in it.
Right. That's right.
If I was a cooking guy, I'd want to be moving around a kitchen, right? Learning the same thing. But it seems to me that movement, you talked a lot about the difficulties of sitting still in ADHD, and it was what on the go. So
I think movement also changes, you get fatigue. If you have the same exact perspective, if you're doing the same task, you're wearing out the parts of your brain. You're using up neurotransmitters, you know what I mean? So I think like movement cognitively and movement physically changes your perspective.
That's interesting.
Yeah.
Okay.
It's kind of like
that's brain fatigue, effectively.
Correct. Yeah. Yeah. It's kind of like, I mean, we don't have camera flashes so much anymore, but kind of like in the olden days, you used to see a camera flash and you have a blind spot for a second. That's temporary, but you've like run those neurons out of neurotransmitters temporary. It was like a really intense focus in one part of the brain or one part of the retina, and it can't work anymore. It's like, whew, it has to wait to rebuild and get going. So, I mean, I think we have biological energetic needs in our brains, and whether we're sitting still or cognitively focusing on one thing, I think we also fatigue those networks.
Makes perfect sense. So one of the challenges of working with children who have been diagnosed with one thing or another thing is, I find, twofold. One, and I want to ask you some questions around this because I think a lot of people listening will be having these challenges too. First challenge, you have a kid that's been told they need therapy. I have never yet met a kid that wanted therapy. I've met lots of kids that would like to play. I've met lots of kids that would like to do interesting stuff. I've met lots of kids that would like to have fun, but I've never had a kid walk up to me and say, Rupert, what I really would like today is some therapy. And so if I'm saying to a kid who's a developing brain, day in, day out for a decade, you need therapy, let's go to therapy, let's go to the therapy session now. Oh, it's time for your such and such therapy. It's not that the therapies are bad, it's just that it's sending a message to the kid that they need therapy at all, which has to be not a confidence giver. That's the first thing. The second thing, of course, is that if attention where we began and the value placed on sitting still to learn, even though it may not be natural, gets to a point where you then say to the child, not only do you need therapy, but you need drugs. We're going to alter your brain with these drugs. And then, indeed, if you stop taking those drugs, there will be a negative effect because there'll be some sort of withdrawal. And then the child's in front of me, how much of this child authentically am I dealing with? How much am I dealing with the medication? How much or how little is that medication blocking the authentic experience of the world, of the brain's ability to process the information? Some would say, well, it's the medication that's allowing him to process, and others would say, no, actually it's blocking. And the child's sort of an innocent in it. They're just sort of trying to get through. And then you have perhaps that child grows up and is medicated till the day they die and is never experiencing the world without that. I'm not necessarily anti-medication in terms of if you're in a crisis, I mean, shit, you need an antibiotic, right? But what I find alarming about behavioral modification medications is that there's never an exit strategy. It's not like an antibiotic that they say, take this for 10 days. And then when the symptoms go away, stop taking it. Or you'll wipe out your gut flora or whatever. They just say, no, stay on this stuff for the rest of your life. Effectively, there is no, I've never heard of anyone being given the exit strategy when they're put on. So that's the brain and the nervous system. That's the thing that you are working with in your field. If we give a kid that's having trouble sitting still a drug to sit still, what does that do to the developing brain? Do we even know?
I would say we know something, but probably not enough. And, I have one thing we know, I guess one thing we know for sure is that the drugs do not work well for everybody.
Mm.
And what does it mean to work well again, right? This is again compared. I think that there's a lot in what you're saying. One is like, how do we involve the children in these decisions about interventions, whether they be therapeutic or behavioral? And like, are the parents just overwhelmed and they need the kid to function in the society that they've been born into? And they're hoping for the magic pill that suddenly makes the kid look like the neighbor's kid, right?
Yeah.
Which I think almost never works. And how does the kid feel about this? I think it's quite interesting because in particular, receiving a diagnosis and then the interventions that occur accordingly from a like sense of self perspective, it seems different when it happens in childhood and adulthood.
Absolutely, 100%. And I've met plenty of adults that wanted therapy because that seems to be an adult sort of decision, adult
Right.
self-expression.
And adults that get diagnoses and they're not crushed by it, they don't feel other, they feel relieved and they're like, oh my gosh, now I have a plan.
Right.
And, there's like a way moving forward. And I think, for a lot of these drug interventions, there are adaptations. Like your brain does always, whether it's antidepressant or whether you're taking Ritalin or anti-anxiety meds, like you are intervening with this neurochemistry and your brain will try to adapt accordingly. It will try and move around that system in ways that like create adaptations and tolerance and so forth and so on. So, some kids do feel a lot better they feel better. I think I guess I want to know how you feel and do you feel better and do you feel better able to meet the demands of your day on these medications or do you not? And is that coming from the kid or coming from somebody else's definition of what it means to be good? And are we sort of like, is this akin to like, we're modifying our children to fit into this like cookie cutter template of what normal means. So for me, I think understanding how the kids feel, but also this identity around being labeled, to our point of other and being told that there's something wrong and that you need to fix it. I think I would love to see kids' involvement in what is it that you would like? What do you find easy? You said you asked the kid what they like and what they hate. What is it that you find easy? What is it that you find hard? Is there anything you'd like to get better at?
Well, right. I mean, that's the first question is usually what do you feel like doing?
Yeah.
Yeah. And I've got some intel about what you like. So I've sort of set a few things up, but you might want that one. You might want that one. You might want that one. And it might be completely different to what I think. So as much as possible, if you can answer me, I'd love to know. But we never if someone comes out to a horseboy place, for example, we never call it therapy. It's a play date. It's always a play date.
That's so cool. And I'm sure it actually is too.
Well, it has to be, otherwise it won't work. But it's just, we realized very early that to even use the word therapy was kind of depressing, for a lot of the kids. But it doesn't mean what you do can't be very therapeutic, but that's not the kids' problem. That's sort of up to us to sort of deliver under the table, if you like.
It's funny that you said play date because I had this aha moment for my own self and with my own horses. And I think this is relevant because in both of these cases, I think you have to think about short-term learning and long-term learning. And it's kind of like, I don't want to use the battle and the war, right? But like, are you learning how to do X, but also learning that you are broken?
Yeah.
And not good enough. And, this. Or are you learning how to work with the grain of your nature, learning how to be successful with the tools that you have and how does that change your sense of self? And this is the thing that it's just so sad to think that like by kindergarten kids already have a sense of, do I fit in? Am I good in school? Does my teacher like me? And how much that scales up to what they, again, to curiosity versus threat, to trying. Like I have yet to meet a person who is super excited to try something that they're quite sure they're going to be crap at. Right. So like,
well, particularly if you feel that there might be some adverse reaction to being crap at it.
yeah.
Like if being
Even
crap is
that.
fun, it's like, I'm going to try and jump off this
Yeah,
thing.
that's
I'm
fun.
going to
Yeah.
land on my ass like a jackass. That's
And
fun.
then laugh your ass off. Yeah.
But
So I had this when I was working with my horses the other day. I had this just new idea of success because I'm thinking about the long term. For me, I don't really care if I can, ride a high school dressage test ever with them, but I am quite curious to see what I can learn to do with them. And then I thought, like, my idea of success is that every training feels like a play date with mom, because I think that sets me up for the long term. Like if the only thing my horse learns is that learning is fun, then what can I not do?
Right, exactly. And if I do find that it's stressful for me or the horse, can I change it somehow?
Right.
And what are the options for changing it? Can the person who's teaching me do it another way?
Right.
If not, do I need another teacher? Yeah.
Yeah. And I think that it's important in this space to acknowledge that it's always a little bit stressful to be doing something you don't know.
Well, not, so is all stress
a little
necessarily
bit
bad? Because
no, exactly.
Right, because
exactly.
And there can be fun involved in stress. I'm just thinking about myself. I like to cross country jump. So if I'm heading in a cross country jump, I'm always shitting myself because I've had some bad wrecks. I know what can happen, but I love it. So I've got my sympathetic nervous system going, but it's also excited and kind of, maybe that's basal ganglia. And it's
because they can remember all the times that you made it more than you wrecked.
Exactly. And it's just such good crack,
Yeah.
So all of those things come together where there's a trade-off between the fear and the curiosity and the excitement and so on. But if it were to go beyond a certain point, like if you were to put me at a fence that I just know I'm not going to get over, then, well, sure, there'd be no enjoyment in it. Or if I felt that there'd be some really adverse shaming or something, if I didn't make it, or if I backed away from it, maybe that would be more like my upbringing. If I said, "Oh, just not feeling it today," so I was pushed to go at fences. The culture was to be kind of brave, but not wise. So I learned that, and my fear of being censored as a coward overrode my knowledge that I probably would wreck and I probably should back away, that the conditions were not right for whatever. And I was more afraid of the judgment that would come, so. But that comes back a little bit to my mind to the drugs thing, because if I'm seeing an overwhelming number of kids who are on these drugs, it's not like, oh, it's just one or two, because it's not just the kids that come to me, it's like half their classmates or more. It's so many. And at that point you're going, does every single kid that's on actually need, like, what, like, so many, like this percentage? How do we survive as a culture at all before this then? If this is like such a problem that we got to have all these medications, that, like, how did we possibly come up with the internal combustion engine or anything, or the wheel? But we did. And in other parts of the world where they don't have those things or do those things, why are they not all just failing? Because they're not, right? So we must be creating, therefore, a society where things that are not disorders are perceived as disorders.
Correct. And I also think a society where we're looking for easy fix, a magic fix. And I think there's whether you're selling someone eye cream or a pill for their kid, at the root of this is a belief that you're not good enough.
Which comes back to not safe, right? So the subject of drugs brings me to something else I'd like to ask you about. So states of altered consciousness. So we know that altering the consciousness is actually part of the human species thing. We've been doing it a long time, it seems. Not just by taking mushrooms and ayahuasca, but also in those places of the world where those things don't grow, where there are no psychotropics, repetitive dance to go into a trance, to go into an altered state of consciousness.
What?
So presumably states of altered consciousness actually can be very good for the brain. And presumably some forms of them can be less good for the brain. But it seems that the brain actively seeks this out, and that it functions as part of our healing systems. Do you know much about what parts of the brain are involved with that, with the seeking out of altered states of consciousness, and what parts of the brain seem to benefit and so on?
Yeah.
Can you
I have
talk
an
to us a bit
idea.
about that?
I have an idea, and I'm also looking at the clock because my class starts in 20 minutes. So
Well,
I'm
we
going to
can-
tell you, though.
Okay, and
I
also
think this is
could be
really-
the first of 2 or even 3.
Yeah, oh my gosh.
We got
heck
a lot
yeah.
more ground to cover, and I
Yes,
haven't even begun to
yes.
ask you about horses yet.
Yes.
Horse brains.
Yes.
So
Let's
we
do
got to
it.
get there. So listeners, we will get to all that stuff.
Yes.
But today we're
let's-
going to do what Chantel has time for. Okay.
Yes, thank you. So I think first and foremost, perceptual curiosity, right? I think that the same reason we look for different tastes, sensations,
To
and
give
so
us
forth in the
perspective.
real world gives us a perspective and broadens our sense making.
Nice.
So that's what draws us to it. But I just read this paper that I am kind of obsessed with that's about dreams, and some of the people in my lab didn't like it because it uses AI and computers as a way of explaining why we need this. So you're like, what's the healing benefit? So the idea with the dreams was that we take our sort of narrative story structure. The part of the brain would be called the default mode network. It's kind of where our mental model of the world and our place in it resides after, hundreds of thousands of memories and facts and learning and personal narrative settle into this default mode network, which is where we store the way we understand.
Is that located in a particular geographic area of the brain?
It's located in pretty much all lobes of the brain, but yeah, it's kind of in the central parts of the brain, the temporal lobes, and these parts of the brain turn on when you mind wander, turn off when you're on task. So, and they're, very characteristic. I could tell your brain from my brain easily by looking at our sense making kind of default mode network. So the idea is that when we dream, we take, the reason dreams are kind of like fantastical and like they have like combination of things that are just normal and things that are like totally weird, but they're always story-like, because your brain is trying to avoid overfitting, which means I've sampled a lot of experiences over and over, but there's this space in between that is unknown. And so I might make a wrong conclusion because I haven't gone there. And what I think I find this just so evocative, this idea that, well, when you sleep, your brain puts noise into that story system to help you explore the in-betweenies. Like, have you ever had a dream where you're hanging out with your son and you're like walking through the forest and everything is totally normal, except your son is actually not your son, like the person doing business as this person, you're perfectly willing to accept that this person is X, although they're like the wrong gender, the wrong age. It's just like a completely different person. So they're like, it's like you have known actors and agents, but they get all scrambled up, and then you just tell a story and your brain goes through this set of experiences. So I believe that like some of our hallucinogenic experiences, not only are they like increasing plasticity with serotonin, but they're also like, they're exploring the in-betweenies. They're allowing you to experience something maybe you couldn't ever really experience here.
Got a question.
Yeah.
You just said something. Why does serotonin increase plasticity?
It's a great question. We don't know, but we know that a lot of the hallucinogenic drugs that seem to have mood rehabilitation effects work on serotonin. What we don't
Like
know.
psilocybin or psilocybin
Yes,
rather.
yes. Yeah, exactly. But we don't know why, like serotonin reuptake inhibitors, like antidepressants, we don't know why they don't make you hallucinate, why they don't have the same kind of like learning effects. Oh, this is my alarm just telling me I have a couple minutes.
Okay, well, that is our pause mode.
And so that is like, so it blows my mind. Like I said, it's only a theory, but this is, to me, these two things make sense. The desire to see, feel, experience different things, and that these altered states of consciousness, to some extent, depending on the adventure you've chosen, allow you to experience things you couldn't really experience in this world. And that, like dreams, there's this idea of what you learn allows you to predict the future, but we tend to sort of have similar experiences over and over, and that leads to something called overfitting, where you develop like superstitions and you've like correlated two things together that aren't really related. And so your meaning model likes to like, let me just
Repeated thoughts
inject.
becoming beliefs. Right.
Yeah.
Interesting. So, and it's interesting your point about why doesn't the artificial serotonin uptake thing work in the same brain-gasmic way as the real thing? Because I guess it's not the real thing,
So.
And I guess
Mother Nature gave us those magic mushrooms for a reason.
Like oxytocin, right? A shot of oxytocin gotten through the natural ways is way, and give it Pitocin will bring down some breast milk, but it won't make you feel.
That's right.
Eureka. No. Yeah.
No.
We're clever monkeys, but I guess nature's always best.
Right.
Listen, there's so many more questions, and I wanted to get into the quantum aspects of the brain. There have been some interesting studies in the last year on this. I wanted to get your take about the microtubules within myelin and all that stuff. And I want to go into the horse brain thing, people talking about.
And how we understand horse brains.
Right.
We'll have to do part 2.
So let's do part 2. So yes, we will ask if horses have prefrontal cortexes, and if they don't, why do they seem to behave as if they do? And I want to ask all these questions. I'm sure that the listeners want to hear them. So shall we reschedule a part 2?
Yes.
And then
please.
What we don't get to that, we'll do in a part 3.
Yes. And then what we don't get to that, we'll do in a part 4.
Super.
When I come to live with you in Spain. I don't know if you're
Well, there is also Tribe Day
that.
coming up. Horseboy Tribe Day in Ireland, August 9th to 11th. Just put it in your diary.
Oh my gosh.
A big old piss up at Kilcloon, which is the big horseboy centre just outside Dublin. We'll be camping out. And
it would be like the real life version of our Irish singing in the lobby of the UK.
That will be it. Yeah.
Oh my gosh.
Yeah, with some brain science and some ponies, some actual ponies.
Oh, that'd be so cool.
There in the field. Yeah. So also for listeners, if you're listening to this before August 2025, it will be August 9th to 11th, Horseboy Tribe Day. You can find out on our website. All the really cool people will be there. Cool because of who they are and what they do. And they're worth talking to. Hopefully Chantel Prat might join us. If not, she'll come down to Spain, where other listeners can join us too. All right, listen, thank you so much. The Neuroscience of You, right, is the book that people need to pick up. And the exam will be during our next podcast. So, just memorize pages 150 to 225. You should be fine. Okay.
But only if you feel curious about it.
I'm going to read it. Brilliant. Okay, thank you so much.
Thank you. I will
see you next time.
Soon. Yeah.
Okay. Yeah, we'll
take care.
We'll book it for the next few weeks.
I hope you enjoyed today's conversation as much as I did. If you like what we're doing here, please do like, subscribe, tell a friend. It so helps us to get this valuable work done and the message of equine assisted stuff out there. And if you're interested in more conversations, you might want to check out our Live Free, Ride Free podcast. And if you'd like to support the podcasts, please go to rupertisaacson.com and click on the Patreon link. If you're a professional in the equine assisted field or are considering a career in the equine assisted field, you might want to check out our 3 certification programs: Horseboy Method, Movement Method, and Taquine Equine Integration. You can find all of those over on newtrailslearning.com. And finally, if you want to check out our cool rock and roll themed merch, back on rupertisaacson.com, please click on shop. You'll find all kinds of fun goodies there. And if you're looking for a way to spend time until the next podcast, you might want to consider reading the books that kicked all this off: The Horseboy, The Long Ride Home, and The Healing Land. So see you next time on Equine Assisted World. Join us for the adventure.